Welcome to section 9.21, systems of equations in 3 or more variables. This is day 1, and I just wanted to let you know right off the bat, those of you who are not fans of handwriting, if you find every single way you can to not do the shortest possible way of handwriting stuff, this is not going to be your day. I'm really sorry. It's going to feel because I was one of those people. I can highly relate. I did not enjoy handwriting. I, as a student, as a math student, I tried to find my way to figure out how I could do as little handwriting as possible. And I just want to say, I'm sorry, this is not going to be your day. I had to take the long way and realize only after many years that at this point, the very absolute best thing you can do is just get over it and try and figure out a way that you can say, okay, I'm going to write this stuff out. I'm going to trust Bergman. I've trusted him this so far. I'm going to trust him the rest of the way, and I'm going to do what he says and write out stuff. For those of you who are cool with handwriting, then that's great. It's going to help you well, and just if you're good at note-taking, then great. I want to remind you of what the elimination rules were from the previous section. We could take an equation and multiply it by a constant. Like you can take any equation and multiply all the terms on both sides by a particular number. And then you can also add it to another equation to produce some sort of an equivalent system. It's going to be the same here. And one more rule that is you can also switch equations. Like if you see an equation on the top, you can put it on the bottom. If you see an equation in the middle, you can move it to the top or bottom, wherever you want. Those are basically the rules that you need. And so we're going to start doing things. I'm going to start off with just 2 equations and 2 unknowns to just get a sense for how this is all going to look. Because you could solve this using graphing, you could solve this using elimination, and you could solve this using substitution. But we're going to refine what we know about elimination and make it and just tweak it a little bit. Here's what I mean. If we're going to use elimination, then we can choose, for example, we can choose to eliminate the x's. And so what I'd do is I would take this top equation, and looking at this positive 20, I'd multiply it by negative 20 so that I get 20x and negative 20x. Then I'd be adding the top equation to the bottom equation to eliminate the x's. And you can see we achieve elimination here with a 0. Now, I know you're going to want to say, but Bergman, I don't want to write the top equation here. I don't even want to write the 0 or the plus. I just want to write the negative 75y is equal to 75. Please, trust me in that what we're going to... That would be true for only a system of two variables, like a system of 2 equations and 2 unknowns. It would be true here, and I understand that, and you'd get y is equal to negative 1, which we do, in fact, get. But I just want to fast forward. Maybe it would help. Check this out. When you're doing like 3 equations and 3 unknowns, wow, you have to do what's really going to serve you is to get in the habit of rewriting the entire system over and over and over again. These are all equivalent systems, meaning they have the same solutions, except that, as you can see, getting down here, this system is equivalent to this system, but now we can see that this system, the solutions are much more easily just read off here because you have x, y, z, and a whole bunch of zeros. So every time I draw this squiggly little line, it's a recopying of the entire system, 3 equations every time. And I know that sounds like a lot of handwriting, but trust me, other math teachers would agree with me. This is not something I'm just coming up with myself. The best thing to do, the best, most reliable way to get the answer right the first time, and therefore it's really the fastest way, is to rewrite the equivalent systems. So this is the original system, and I'm going to rewrite this system here. What I've done is I've multiplied the top equation by negative 20 to get this, and now so now I have an equivalent system here. I'm going to add the 2 together to replace the bottom equation. The top equation remains unchanged. And now that I have the top equation and the bottom equation here, y is equal to negative 1, you can substitute negative 1 into here, and you get x equals 3. So we know the 3 comma negative 1. Basically, what this overall looks like is you have these numbers in these places, a, b, c, d, e, f. And the first thing we're going to do every single time is we're going to divide the top equation by a. And so you'll just get x, like you go from an ax to an x. because you divided it by a. And you won't exactly get b, you'll get a different number, but so that's why I'm calling it b prime and c prime. And then the next thing you're going to do is take this top equation and multiply it by negative d to add it to negative d and add it to the bottom equation so that you get this as 0 right here. And I know you won't exactly get the same e, it'll be a different e, but this is, so we'll call it e prime and f prime. The point is we're going from ax to just x, and then from dx to 0. And then once you know this is 0, you can divide this bottom equation by some number e prime to get a different number f prime. And then once you know what y is equal to, you can back substitute and figure out what x is equal to. That's the overall roadmap. It's going to be a very similar roadmap here when you get to 3 equations and 3 unknowns, and we'll talk about that in a second. But let's actually solve this now. So the first step is to get x all by itself, to remove the 2, so you can divide the top equation by 2. Thank you, textbook, for making it easy for me to do. We get x minus 2y plus 3z is equal to 11. Recopy the whole system. Then we get 4x plus, so you can see it's just recopied. The lines 2 and 3 are not changed. Then I can take this top equation and multiply it by negative 4 because I want to get rid of this positive 4. If I take the top equation and multiply it by negative 4, this is negative 4x plus 4x is nothing. Negative 2y times negative 4 is positive 8y plus 2y is 10y. 3z times negative 4 is negative 12z plus this negative 3z is 15z. 11 times negative 4 plus 4 is going to be negative 11 times negative 4 is negative 44 plus 4 is negative 40. Okay, so that's the second line. It's now changed, and notice we have a 0. Third line. Okay, so I'm going to take this x and I'm going to multiply it by negative 3. Why? To create a 0 here. If this top equation is multiplied by negative 3 and added to the bottom equation, this is x times negative 3 plus positive 3x is 0. Negative 2y times negative 3 is positive 6y plus this 3y is 9y. 3z times negative 3 plus is negative 9z plus negative 1z is negative 10z. 11 times negative 3 is negative 33 plus positive 4 is negative 29. All 3 equations are now different. But the great thing is that we have x here, 0 here, 0 here. So that's progress. If you wanted to just zoom in right here and forget the x in the top equation, what you see right now is we have a system, 2 equations and 2 unknowns. And you could solve, technically, if this were existing all by itself, you could solve this with systems of equations. We're just going to keep on going. Like this, you can see the progress that's being made. Now, what the roadmap says, we're going to take this middle equation and we're going to divide it by 10. Dividing all the terms on both sides for just middle equation, we get 0. We get 10y divided by 10 is y, which is what we chose 10 for this reason. We wanted to get y all by itself. Negative 15z divided by 10 is negative 1.5z. Don't fear that decimal. It's not too bad. Negative 40 divided by 10 is negative 4. Great. Recopy the top equation, recopy the bottom equation so that you can use it here. Now, we got zeros here. Now we're going to get zeros in the y, I call it a column. So after we're finished this next step, we're going to have y and then 0 and then 0, which is great. So in order to do that, we see a negative 2 here, so we have to take this middle equation and multiply it by positive 2. This middle equation times positive 2, 0 times positive 2 is 0, the x is unaffected. Y times positive 2 is 2y plus negative 2y is 0. Negative 1.5z times positive 2 is negative 3z. And it also happens to, when you add it to positive 3z, you get 0. That's a happy side effect. We didn't expect that to happen. We didn't arrange for that to happen. Negative 4 times 2 is negative 8 plus 11 is positive 3. So we get x plus 0 is equal to 3. 0 plus y minus 1.5z is equal to negative 4. We're going to do the same thing down here. We're going to arrange to get this 0. In order to get this 0, we have to take the middle equation and multiply it by -9 to add it to this positive 9y to get 0. So negative 9 times negative 1.5z is, what is that, positive 13z plus negative 10z. It gives you the positive 3.5z. Sorry, I misspoke. This is negative 1.5z times negative 9 is negative 13.5z. As positive 13.5z. When you add it to negative 10z, you get positive 3.5z. Negative 4 times negative 9 is positive 36. You add it to negative 29, you get positive 7. Now I have 3 equations, 3 unknowns, lots of zeros appearing. Aha, I can take this bottom equation and divide it by negative 3.5. That's on the roadmap. We have to get this to be just z, not 3.5z. So when you do that, we get 0 plus 0 plus z is equal to 2. Recopy the whole equation, the other 2 lines, so we get the entire system. And now it's a lot easier to see after we have z is equal to 2. We can multiply this by 1.5 to eliminate the negative 1.5z. Z times 1.5 is positive 1.5z plus negative 1.5z is 0. So we get a 0 here. 2 times 1.5 is 3. 3 plus negative 4 is negative 1. And voila, we have x is equal to 3, y is equal to negative 1, and z is equal to 2. Write them in alphabetical order, 3, negative 1, 2. Whew! That is a beast. And that's what we're doing all day, every day, conquering the beast. You got this. While we're talking about conquering the beast, I just wanted to drop an audio check and say that in 1985, the Academy Award winner for Best Picture was Amadeus. Watching this movie will make even the most hardcore punk rocker fall in love with Mozart. And if you don't believe me, you should check it out because it's actually a pretty cool movie. A lot of unknowns came out of that. Actors came out of that movie as real famous people, and they had really famous careers after that. So, just really well made movie. Let me show you. I'm gonna show you what the roadmap would look like here. If you have just in general, you're gonna get 3 equations and 3 unknowns. And we're gonna ask you to solve it by hand. So the first step would be to take equation 1 and divide it by a. Just like we did here, we divided this by 2 to get this. Once you have just x and not ax, you can use it to eliminate e and k. Then you take equation 2 and you divide it by f, so that you get just a y right here. And then you use equation 2 to eliminate this b, the whole term by goes to 0, and the whole term ly goes to 0. Then you take equation number 3, and because you have a 0 here and a 0 here, you'll divide it by m. And then you'll use equation 3, because it's now just z is equal to some number, you'll use that to eliminate these z's up here, and you'll get your answers for x, y, and z. All right. Let's do this one more time, shall we? We're not going to do anything else differently. The roadmap is still going to be the same. Oh, and check it out. We don't even have a number here. The first step would have been to divide the top equation by some number up here, but it's already just x, so we can use it to eliminate this term and this term. I see a positive 2, so I'm going to take this top equation and multiply it by negative 2 so that I get a 0. So x times negative 2 is negative 2x plus 2x is 0. 2y times negative 2y is negative 4y, plus negative 4y is negative 8y. Negative z times negative 2 is positive 2, plus z is 3z. 5 times negative 2 is negative 10, plus 0 is negative 10. Let's do the same thing for the bottom equation. X times I see a 3x here, a positive 3x, so I'm going to multiply the top equation by negative 3, so that when I add them, I get a 0. X times negative 3 is negative 3x, plus 3x is 0. 2y times negative 3 is negative 6y, plus 2y is negative 4y. Negative z times negative 3 is positive 3z, plus 2z is positive 5. This should be a z, not a y. 5 times negative 3 is negative 15, plus positive 3 is negative 12. Make sure you have the entire system recopied. I'm going to divide this middle equation by negative 8. Negative 8 goes down here. And so now I'm just going to recopy the top. This middle equation divided by negative 8 becomes 0 divided by negative 8 is 0. Negative 8y divided by negative 8 is just y. We've arranged it to be this way. 3z divided by negative 8, fraction. We got negative 3/8 z. Okay, power through Bergman, you got this. Negative 10 divided by negative 8 is positive 10/8, or simplifies to 5/4. Okay, we got this. Roadmap says that we have to now that we have y is all by itself, we know what y is equal to. We can use y to eliminate 2y and negative 4y. I see the positive 2, so I'm going to take this middle equation and I'm going to multiply it by negative 2 and add it to the top equation. So y times negative 2 is negative 2y, plus 2y is 0. Boom, 0. Negative 3/8 z times negative 2 is positive 6/8 z, or positive 3/4 z, plus negative 1z is going to be negative 1/4 z. 5/4 times negative 2 is going to be negative 10/4, or negative 5/2. Plus positive 5 is going to be positive 5/2. Then we've got down here, I see a negative 4, so I'm going to multiply the middle equation by positive 4 so that I create a 0 right here. So y times 4 is 4y, add it to negative 4y, you get 0. Negative 3/8 z, 0 times 4 is 0, you add it to 0, you still get 0. Great. Negative 3/8 z times positive 4 is negative 3/2 z, plus 5y gives you 7/2 z. Then 5/4 times positive 4 is 5, times negative 12 is negative 7. So I know it looks ugly, but we're going to power through because it's correct so far. I've checked it already. 7/2 z, we're going to eliminate this 7/2 by dividing all the terms on both sides of this equation by 7/2. So you get 0, 0, c, and then is equal to negative 2. You might say, Bergman, why do you have to keep on writing these zeros? I think it's good. It doesn't take too long. It's not a whole lot of handwriting, but it does. The huge benefit is that it does keep things organized in like rows and columns. Everything is neat and organized, and it helps you remember that you've already eliminated these things. Students who choose not to write the zeros often start to fall into like handwriting. I can't read my own handwriting kind of stuff. So I think it's studentship-wise, it's best to leave the zeros. But now that we've divided this bottom equation by 7/2, you get z is equal to negative 2. And then, so then I see the negative 1/4, and I can take this bottom equation and multiply it by positive 1/4 so that this entire term goes to 0. When I do that, you get negative 2 times 1/4 is negative 1/2, and add it to 5/2. And I want you to do that. Take negative 2 and multiply it by 1/4 to get negative 1/2. And what do you get when you add 5/2 and negative 1/2? I'll do the middle one. Negative 2 times 3/8. I see the negative 3/8, so I multiply by positive 3/8 to get elimination. Negative 2 times 3/8 is negative 6/8, or negative 3/4. Add that to 5/4, and you get positive 1/2. So here's our system, and you can see you can express the solution like this. Boom. I would like you to start 9B1. Go ahead and copy the problem list, do the first problem, and I will see you in class.